Hey Darian and crew. Hope you guys are doing well. Excited to hear about your robot and things you're doing for competition. Sorry I can't jump onto a call with you directly, but thought I would record this so that you guys we can walk through some of the steps of coding. Potentially getting you guys to auto bring back the catapult, bring it back down. Um, but just talk through some of the steps that we go through when we're trying to design something like that. So if you see, I've got a Swish bot here that I'm using as an example because it's very similar to what you guys have going on, especially in this part of it. And so really what I want us to focus on is how these motor groups work. So this motor group for the catapult ends up spinning these. Let's see if I can get it set still so I can get a good view of it. Spinning these back motors forward until they engage the pulley for the catapult. And then at that point, a ratcheting system, as it goes down, is pulling down that catapult all the way. Now at this point, the only thing that is engaging this catapult pulley is this ratchet in the back, those green gears. And those are holding those top blue gears in place so that they won't release the catapult yet until you guys are ready to release it. And once we do, the motors pull that away and then the catapult launches, which I'm assuming is where you guys are at this point. And so I think it's a very good question that you're asking and that you're trying to figure out is how do we make it so that during the match we can bring that down quicker so that we're not spending most of the match waiting on that catapult to drop back down into place. And if we can do that automatically, it makes it even better. So I'm going to bring up the base Swish code. Now this is straight from Vex, so it might be different based on things that you guys have already changed or not changed, but this is just figure we started at the same place, at least from my perspective. I accidentally deleted some code there. Okay, let me see if I can zoom in a little bit as well so you guys can see that better. So this is just a note that they put in there initially with, but I'm not going to use it for right now. What I want to do, when I have anytime I'm starting to code anything, I make the students, and even I do this myself as a software engineer, I write down the steps that I want to happen with my code. And that really helps me keep things focused as I'm going along so that I know what I'm expecting at each step along the way. And so I'm going to bring just some comment blocks out here so that we can talk about that. So what we want to happen first, we can assume that we're going to launch the catapult first. Okay, so we'll just say that this is a catapult launch. Now, which button are you using on your controller to do that? For my team, we are using if I can get the webcam set up right. We are using some of these top buttons on the controller. So that may or may not be the same for you, but if we look at the code block that was with Swish and we click on the controller, it looks like the intake is using the buttons on the left and the catapult motor group, because we have two motors bringing down the catapult because it requires that. Our rubber bands are pretty tight. So we're using a catapult group, release and lower, right here. So we're going to modify those. That's what we want to do. So a launch is going to be this R down. Then what do we want to happen? So the catapult's going to launch, and then we want it to automatically come back down. So launch, we're just going to say it's going to wait for some period of time, maybe a second or two, because if we start pulling it back down right away, then it might not have be able to finish its full release. So we're going to wait, we'll just say 2 seconds. This is an opportunity for you guys to test it and see what number works well when you do this. Then we want our code to retract or lower is what it says over on our controller. And that's going to be the R up button. How far do we want it to lower? That was the question, and we've struggled with this a lot with our team this year. By default, Swish has you add a sensor at the bottom, and the sensor is going to be our intake optical sensor that you may have added. It looks like it's on port number 5. We're going to lower it until optical sensor detects something. This is where we ended up having a lot of trouble, and we ended up kind of scrapping this idea, but I still want to talk through it with you in case you guys can get it where we couldn't, which is great, but then give you another option that might help you move this along as well. So we're going to retract or lower this pulley, those motors, until this optical sensor detects something, because that's really what we have to use. If we said lower it for 5 seconds and our motors are trying to go 1, 2, 3, 4, and it's already lowered and it hasn't reached 5 seconds, then it's not going to let me run any more code after that, because it has to finish that 5 seconds. So we have to find a good way to determine when we want the motors to stop bringing the catapult down. And that's been a really tricky thing. An option that you might be able to get working, we had our first competition before we were able to get this fully working, is to use a touch sensor instead. One of those bumper sensors that have a little something on the top that push down. You can configure that somewhere down at the bottom of your arm and say retract the motors until that bumper switch is pushed. And that might be a good way to make this so that it actually stops appropriately for you. But regardless, that's what we want to happen. So these are kind of our steps when we do this. One thing to be really careful of, if we're going to program our own buttons, if we want them to do something special out in this code, different than what is in here, because these are buttons that we're just toggling and changing as we want, then we have to remove them from the controller. And we do that by clicking on the item in the controller, removing it, and then click done. If we don't, our controller settings are going to override the settings that we have out here in the code, and it's not going to work well. We've just had too many teams work on that. So just make sure, if you're going to override any of these buttons to do something else on the controller, make sure that we remove them from the actual controller piece here. So we always start out with when do we want these things to happen, and those we can change all of those in the events section of our code blocks. The events are where we're going to find all of the actions that we want to happen within our code. So if we go down to when controller button E up pressed, we can go down here and we can find R up and R down. So we want to click on R up, and we want to bring another one over and R down. So obviously this code block, whenever the controller button R up is pressed, all of the code that we stack under this code block is going to be executed. When we press the R down button, everything under this stack is going to be executed. Now, it may be that we'd only need one of these at this point if you're going to do everything going through a loop and that it's automatically retracting. We may not need one of these, but it's good to have them out here just so that we can understand everything that's going on. And so what I would end up doing, I like straightening these up. I try to keep my code clean so that I can read it and move to the to the right places. So, what are we going to do at the beginning of the match? That's the thing. Is it already going to be brought all the way down the catapult, or is it going to start in the up position? I would assume you're going to start at the bottom, because you're going to match load and put that ball right into your catapult. And so we want, the first thing we're going to have to happen for our robot is we're going to launch. Okay? So how do we get our robot to launch the mechanism that we have here? We just talked about it a little bit, but really what we want to have happen is we want this motor group with the ratchets in the blue to move away from the pulley at the bottom. As soon as it moves away, that can spin freely and everything can release. So, we want that motor group to release. So when the control button up is pressed, you can go to motion. And I want you to bring the spin catapult group lower and make sure you get the one that has for a certain number of degrees. Don't just get the one that's releasing for right now. Spin catapult group. We're going to change lower to release. And we really only need to release it a few degrees in order for it to disengage and allow that pulley to release so that the catapult can launch. So I'm just going to change this to maybe 5 degrees. You guys can change this number if it works better for you another way. By all means, test it, see what works well for you. So we're going to spin it for 5 degrees. The catapult's going to launch. Then we're going to, what did we say on our code steps over here? We're going to wait for 2 seconds. So we can go over to control, and there's one that just says wait for 2 seconds. Then we're going to spin the catapult group, spin the catapult group motors back down. We go to motion, spin catapult group lower, and this time I chose the one without anything else on it because I want to use one of those sensors to detect when it's at the bottom. And the way that I do that is I go over into a control again, and there's a block that says wait until, and it's empty at this point. So what this code block is saying is that we're going to spin this catapult group in the lower position, start ratcheting it down, and we're going to wait until something happens to indicate to us that it's stopping. So if we use sensing, go down to sensing blocks. Now it has, and I haven't tried these, I think it might be interesting to try. It says catapult group is done. And if you have a question on any of the code blocks, we should be able to hover over them and get some kind of indication. Block help. Okay, so this just tells us that the block is done moving. Which I don't know if that's going to work properly for us with what we're doing. It might be something to try. We didn't try this. My teams didn't try it, but that doesn't mean that it won't work here. But I'm going to remove it from right now just to get rid of that. We're going to look at the sensors. So we can drive down to, or drag down in the sensing to intake optical, found in object. This means that optical sensor that's mounted on the front of Swish detects an object in front of it. It's really close to it. That's the hope. I think that's what the way they designed Swish is so that we would use that optical to detect that one of those bars of the catapult are in front of it, and then we can stop what we're doing in the move. So we're going to spin the catapult lower until the intake optical sensor finds an object. Then we're going to go to motion, and we're going to stop the catapult group. Now that's really important, because what that'll do is stop those motors from spinning, and now you're ratcheted down all the way, hopefully, and now you're ready for the next launch. Notice we don't even need this down button anymore, because what happens is we're going to press the R up button, releases it, waits, spins it, waits, and then stops. And actually what we might need the R down for is to just lower our catapult so that it can start at the beginning of the match. So you might just spin it lower on the R down button. This way we can, at the beginning of the match, you can just click on the R down button, it will lower it all the way, ready for the match, and then the rest of the match you just use the R up button. To release it, it will release for 5 degrees, it will wait 2 seconds, it will lower back down until the sensor finds an object, then it will stop the catapult group. So that's how we would implement some kind of system to auto retract the catapult. This part is the most difficult part. What are we detecting? When do we determine when it's stopped? If you can do that and do that well, I think this is going to be really good for you in a tournament, because as you probably already can tell, you spend a lot of time like waiting for that catapult to lower back down before you get the next ball. Another option, and I would probably do this as well as they're auto retracting, but my teams are just using this, and they're not even doing the auto retracting. They just found that they couldn't ever get it to consistently work. The sensors just never worked for them. Not saying that you can't get it to work, and great if you can. It just required more than what the time we had at that point. Something else that you should do, though, is go up to this when started block on your drive code, bring over set catapult group velocity, and change that to 200. This change alone is going to allow you to bring it down faster. Even if you don't implement the auto catapult and that's not working, you still want it to come down faster, and this will actually make it come down significantly faster than without using this. It just makes those motors turn faster to bring the catapult down quicker. So good luck with that. If you can't end up getting these working before the competition Saturday, what I would recommend is to take a picture, screenshot of this code, and get rid of these blocks out here, the when controller button up pressed, when controller button down pressed. Get rid of them and add the code back to your controller so that we can control it that way. Because if you don't, then you may get to the competition Saturday and you may end up with a bot that's just like flinging over and over and over again and get into some kind of loop, and we don't want that. So hopefully you can get it to work, but if not, slide these back off like that, get rid of them, and then just add them back to the controller. Okay? Hopefully this is helpful. If it's helpful, great. Hopefully it works well for you guys Saturday at the competition. I believe it's at Jay County that you guys are going to. None of our teams are going to be there, but hopefully that works well for you. If you have any questions, communicate them to Miss Darian, and she can message me, and I'll try to get specific responses back to you all before, if you have a practice again Friday, I can try to get an answer back to you before then. But hopefully this is helpful. Glad you guys are coding. Glad you guys are doing robotics. That's great. And if you need anything else, please let me know. Thanks.